This video is going to cover three hinged arches. So a three hinged arch is actually a pretty common member that gets used in frames. So this is a pretty realistic problem to see quite often out in the real world. So this isn't exactly too difficult, but we are going to find the magnitudes of the resultant forces at A, B, and C. So those are our three hinges. We have a pin at A, we have a hinge at B, and we also have a pin at C. So a hinge is effectively a pin, so this is a three hinged arch. So to start with, it's effectively just statics. We're going to start by finding what we can. We've got our reaction force AY. We have a reaction force AX. Over at C, we have CY and CX. Now for the hinge that's at B, since he's an internal hinge, he doesn't actually have reaction forces that are showing up on the whole system. So what we can do is start by analyzing our whole system to see what information we can get. So for the whole system, if we start, remember that we have three equations. We have the sum of the forces in the y direction, the sum of the forces in the x direction, and the sum of the moments. Sum of the forces in the y, we have two unknowns. Doesn't really help us. Some of the forces in the x, again, two unknowns, doesn't help us. If we sum moments though, say if we take moments about A, then none of the A forces go there, and Cx also is not going to be present in our equation because Cx acts in line with A. So we could do that about A, or we could do it about C. Either one doesn't matter. I'm actually going to sum the moments about C, because I don't like that 9.2 kip force up there. He's just a little bit awkward. So I'm going to take the easier half. I'm going to do A. So I'm going to sum the moments about C. Over here counterclockwise is positive, and we're just going to see what we get. So let's get rid of that highlighter thing. We'll do it in reverse. We're going to sum moments about C, so AX is not playing a part. So we got AY. AY is going to be going the wrong direction, so minus AY times his distance of 10 plus 6 plus 12 plus 8 plus 10 plus 10. That's a grand total of 56 feet. That's a lot. Then we got our 2 kip force. 2 kip force up here times a distance of 56 minus 10. Right, since that's not there. So he's going to be going in our positive direction. So 2 times 56 minus 10 is 46 feet, plus we've got the 4 times a distance of, well, that's 46 minus 6, that's going to be 40 feet. Then on the other side of B, this gets a little bit easier, we have the 9.2. Again, he's going to be positive 9.2 times his distance of 10 plus 10 is 20. And then we've also got the 3, so plus 3 times his distance of 10. So really big equation, and we're going to get that AY is equal to 8.32 kips. That's all. Now that we have one of our forces here, let's go ahead and simply sum the forces in the y direction and set it equal to 0. Right, since now we have AY we're saying is 8.32. If we sum the forces in the y direction, we're going to have our AY going up, so 8.32, our CY going up, and then all 4 of our forces going down. So minus 2, minus 4, minus 9.2, and minus 3. So CY is going to equal 9.88 kips. So CY is 9.88 kips. Wonderful. We can, again, sum the forces in the x direction does nothing for us right now. We have 2 unknowns and 1 equation, so can't do that. So next what we need to do, we also want to find the forces at B. So we're going to make a cut right here. We're going to cut this member in half. We're going to look at 1/2 of it. Again, I like the A side rather than the C side because 2 and 4 is just easier than 9.2 and 3. So there we go. Again, we've got our internal forces at B, so we're going to have bx and by. Don't forget we still have ax. We found ax or ay. Ay is 8.32. We don't know ax. So now that we have our little free body diagram, again, it's the same thing. It's just statics. We're just going to be using our same three equations. We've got some of the forces in the y, we've got some of the forces in the x, and we have some of the moments. I'm going to go ahead and sum the moments about b to go ahead and start with. So if we sum the moments about b and set it equal to 0, again counterclockwise is positive here, then we can easily find ax, and that's good. So we're going to start, we got our 8.32. That's going to be negative, so let's make some space there. It's negative 8.32 times his distance of 10 plus 6 plus 12, which that's going to be 28. And so he's going to be going negative. Then we have ax, and ax is going to be going positive, so plus ax times a height of 20 feet. And don't forget we've also got our 2 and our 4, and those are also going to be going positive, so plus the 2 kips times a distance of 12 plus 6, which is 18 feet, plus we've got our 4 kip load times a distance of 12 feet. So solve that, and you're going to get that ax is equal to 7.45 kips. So it's just going to go fill him in over here. Ax is 7.45 kips. Again, 3 equations, or well, we have 2 equations now and 2 unknowns, so we're just going to go to using them. We have some of the forces in the y direction. Let's set it equal to 0. So we've got 8.32 going up, we have 2 going down, we got 4 going down, and technically by going up. So if we solve for that, we get that by is equal to negative 2.32 kips. Now all that the negative means is that we drew him in the wrong spot in this half. When we go and break him up again, remember on the other side for by, he would be equal and opposite reactions at the other end of b, and so technically he doesn't actually exist. The positive or negative here is not actually relevant, but because if you look at the other side, it's the exact opposite. But we are going to use these values to find our resultants. Next, we've got to sum the forces in the x direction and set it equal to 0. We've got ax, which was 7.45, and again, bx. Bx is then going to be, again, a negative 7.45 kips. Again, doesn't actually matter that he is negative, just means we drew him in the wrong direction. And now that we have those and we have ax, if we go back to our whole system here and we put in ax, so ax we said was 7.45. If we sum the forces horizontally, we're going to find that cx is also 7.45 kips. Right, so we can, if you want to write it out, we most certainly can. If we sum the forces in the x direction at the whole system and set it equal to 0, we have our 7.45 minus cx, so cx is 7.45 kips. So that is the forces, but it's not the resultant forces. We want the resultant forces. So resultant forces, again, this is kind of like drawing a triangle, right? If we're just going to take cy over here and cx because they're right here, cy is 9.88 going up, and cx is 7.45 going over, and we want to find the resultant force, r. Well, this is just a triangle, and you know how to find the hypotenuse of a triangle. So C's resultant force is equal to the square root of 7.45 squared plus 9.88 squared. So C's resultant force is equal to 12.4 kips. They did not actually ask for direction, they only asked for magnitude. Again, we can go to B. B's over here. So B again is, it doesn't really matter the directions, but B's resultant is going to equal the square root negative 2.32 squared plus negative 7.45 squared. B's resultant is equal to 7.80 kips. And again, if we look at A's resultant, again, he's going to go over and up. So A's resultant, we have 8.32 going up, 7.45 going over. The resultant force for A is equal to the square root of 7.45 squared plus 8.32 squared. So the resultant force of A is equal to 11.2 kips. And that is how you solve a three-hinged arch.